Hi everyone, welcome to Observability Guru. Today we're going to have a very exciting session on AI native full stack observability on AWS with Datadog. So this is going to be a complete hands-on kind of a session where I have developed a insurance specific AI agent which is integrated with a web page which users are able to interact to obtain answers related to their insurance related queries. So what we have done, we want to enable now full stack observability on top of this insurance agent so that we will start looking at exciting things like how we enable LLM observability. Now that we have a LLM part, how is our APM going to change? And then how we look at the real user monitoring, how we look at the log, very important, and infrastructure and continuous profiler. So these are the kind of 6 things we will try to enable for this POC application. I'm very excited to walk you through this and let's get into the work. So just to give a quick overview of what we cover, we will first go through the POC, the application. I'll do a quick demo to you and then we will start enabling full stack telemetry. We'll look at the big picture, what is the tech stack of this application and how we can enable these 6 things which I mentioned to you earlier: the infrastructure, the APM aspects, LLM observability, real user monitoring, log management, and continuous profiling. And then we'll look at pillar by pillar how we can enable these 6 things, and we will look at the concepts, and we will look at what kind of data it's sending into the Datadog as well, and then we'll close off with results and what are the next steps. So just to start, we have built a very nice application called Coverly. It's a Coverly POC app, and it's a insurance agent, and it's not a production grade RAG pipeline, but we want to make it a little smaller version where it's connecting to LLM to provide us uh, the queries, right? So basically what has is there's a knowledge base. When the user asks a question, the that we first take the go to the knowledge base, get the context, and then go to the large language model to wrap it that and provide the answer. So it's again grounded answers only. We are more focusing on keywords, and then we are using DeepSeek via OpenAI SDK. So let me just walk you through about this application little more detail. So here's the application for you. So it's a POC application, but it have kind of like some of the basic stuff, right? And the important thing is it has an agent where we are able to ask questions. So maybe I can ask a question like, what does my monitor insurance cover in case of a EV vehicle breakdown, right? Likewise, maybe we can ask a question about hybrid battery. Yeah, so it doesn't have, so it's not able to provide that view. Maybe we can ask a question about, I am planning to travel US. Does my so we asked that question, it came up with a good answer. Okay, now that you have a quick overview of the application, let's go a little bit deep. So we are using a different set of tech stack. So of course, like everything is hosted in AWS, we're going to use Datadog to enable full stack observability here. We are using Python. So Python is the acting as the key backend service, or the my services are developed using Python. And then we are using uh, UVCon, which is a web service. So it's listening to port 8000 for the incoming HTTP connection, and then hand it over to our Python app. Think of like a Nginx or Apache, but it's a very lightweighted and a Python native web server. So our solution is using FastAPI, a web framework. It's a Python code that defines your routes and validate request response, shape the pedantic, and contains your business logic. Right? So it's pretty much does the work for me. So how this application in high level work is, when a user trigger a request from the browser so that it comes to our UVCon server, then it will send it to our fast API, and from there it will invoke our functions and then go through the business logic and then return the response to UVCon back and to the user again. So those are the key steps involving the functions. So again, like we are using vanilla HTML, CSS for our front end. Observability, we are going to use ddtrace, part of Datadog heavily. And this is again hosted on AWS EC2 instance. So it's a just in one VM at the moment. So just a quick POC. And we are using OpenAI Python SDK as well. And so these are the tech stack. And I just already mentioned to you how it works. So when the first request came in, it will come to our HTTP layer, and then it will go to our workflow, right? And then we have wrap our workflows with LLM to uh, enable full stack observability. One request, pretty much 3 layers. And one of the key thing I want to cover here as well is, uh, these 3 layers are very important. So when we enable our full stack observability for this AI native application, it's key that we enable it at all 3 layers. Next, we'll look at the POC architecture. So gen we have everything hosted on AWS EC2, and the request will come from browser, and we are using Datadog SaaS platform. So here we will enabling some of the key features like APM, then with service map, our LLM observability, log management, real user monitoring with session replay, continuous profiling, and infrastructure monitoring. So those are the key things which we will do part of this demo. So just to summarize what we're going to do, so this entire thing, these are the key things we will enable. So we will enable real user monitoring. So we will get to know what our end users are doing. We will do APM and LLM observability, and we'll also enable continuous profiler. And then we'll look at infrastructure and the logs. So those are the key things which we will focus. So the first thing to do when we are enabling our full stack observability in this AI native application, first thing we have to do is we'll have to enable infrastructure monitoring. Like, I know it's kind of the basic thing, but we had to start from somewhere. And here we will use our Datadog agent and just bring it up in the EC2 instance, which will automatically enable us to see all the infra related the metrics and get access to our logs, the standard logs and everything. Okay, I kind of like log into my AWS EC2 instance, and you can see my agent is already running fine, which is a great news. So now let me come to Datadog console and just check whether my instance is visible. Yes, I'm able to see the instance. Let me go inside and hopefully I am able to see some of the data coming in. The basic stuffs are there. So I kind of like enable most of these things. So you will see the logs, metrics, and others are coming in, but we will go one at a time. So the good news is all the infrastructure related stuff is coming. I'll be able to see my the CPU, the process and memory, and all the other standard stuff. The processors are running and all those things, which is excellent news. So the next stuff we have to do is enable logs. So I am a very methodical person. I like to start things in a particular order. So my mind, the order is you enable infrastructure and then we get the logs ship in. So this is an application, the POC insurance agent application. It's interacting with users to support their answer their insurance related queries. And while it's doing its work, it might encounter exceptions, encounter some runtime errors, or there can be a BAU status updates. So everything we kind of start log into a particular log file in our server. So first thing I want to do is get this log file ship into Datadog because that gives me rich information when I want to troubleshoot issues or any time I want to get more understanding of what's happening inside my application. So my application logs are being written here, right? You can see it's within var log coverly app. So if I go to my application and probably I have a couple of failure scenarios I have built into this application, and you can see uh, the errors and everything will start appearing here. So one thing we will do is let's look at one of the log line little carefully, right? Let's ask something nice. We just ask a question. Hopefully I get a decent answer. And here with this, yeah. So if you look at a particular log line, it's something like this. And here you can see the time and the status. It's a info log, and we also kind of have a log level as well. And then we have the logger, which is the insurance agent, which is sending this data. We have the message, and inside the message we have the tokens and the latency. And one important aspect is we have a DD trace ID and a DD span ID and DD service and DD environment. So all of this data is I have injected when our application start running. So this is about uh, the Datadog injection. So this will what this does is it allows me to correlate my traces with the logs. So if I see a log, I'm able to find out what are the related the traces, and if I see a trace, I should be able to correlate because I already injecting this DD trace ID and span IDs to the log, right? And if you see another the previous one, which probably let us do one thing. Let me clear this up again, right? Okay, and let us see. Probably this is the one exception. It's still again the same approach, right? You have the time, you have the status. It's an error, right? and at the log level, and we have the logger, and we have the message, we have the error related details, and we also have, we should have that span ID, right? Yeah, so we have the trace ID, the span ID, right? So we will come back to this. This is a very important. Once we enable traces, we will able to see how these things get correlate, right? So this is a very important thing you should remember. Let me also show you where we have this configuration in place. Let me, so let me go to the backend, and I should have something called env. Yes. So here I have given my, and here I have my DeepSeek API key, which I will obviously delete after this recording. And we have the insurance chat agent details, like what is the service name, the environment, the version, Datadog site, and then I have put the other agent related configuration. We have the DD log ingestion true, and we also enable the other stuff related to Datadog LLM observability, the profiling. So everything is here. So this is the one of the key files you need to be doing the changes to enable logs and also enable this correlation with traces in future. So once you enable this DD logs ingestion to true, that will do that magic of automatically injecting the trace ID and span ID inside your the logs. So that way that we are able to do that correlation. Next, let's go to our Datadog console and see how our logs are visible. You can see I am in my Datadog console and my logs are coming through. I can see the service insurance. I can see different status, the info, warning or error, and my logs are coming here. It's a standard configuration. You go to the Datadog agent and add uh, the particular configuration, and then agent will start sending. Probably that's something we will check as well. So you can see each log I'm able to go, and because I have done that log ingestion true, so I'm sending both the trace ID and the span ID. I am able to correlate with traces as well. So inside the Datadog folder under etc agent Datadog agent conft, I created the folder for our insurance agent, and we created the YAML file which is looking at the logs in the app log, which is getting generated by my insurance agent application, and we are simply did the configuration and of course enable logs enable true in agent as well. So this is typically what has helped me to kind of configure the logs. Now let's look at the next aspect of our enabling telemetry for this AI native application. Next is the most important stuff. It's about how we enable LLM observability. So Datadog provide out of the box way to enable LLM observability, and it's a very I would not say straightforward, but it's a very convenient way of enabling the large language model observability for your AI native application. And of course, this is the key, right? So when we start building more applications which are leveraging AI, especially large language model, to provide various benefits to our end users, then we want to be on top of and see how people are actually uh, uh, using these applications, and the observability, the granular level details related to how these end users are being served. For here, I am using Datadog LLM obs annotation, which is kind of a nice way to uh, enable uh, the observability piece for LLM. And from a very hierarchical perspective, what we want is we want to get the insurance chat when our agent is having that chat initiation, when we want to know uh, when it goes to a retriever policy, a document or something, and when it goes to the DeepSeek for LLM wrapping, right? So if I just explain to you again, right? Our application, a user goes and asks, does my motor insurance cover EV breakdown, right? That's probably the first workflow, right? Which we want to have visibility. Then inside what it does is it doesn't go to DeepSeek and ask, right? Just this guy's motor insurance support EV breakdown, because DeepSeek doesn't know anything, right? It's just a large language model. So what it does internally, we have a knowledge base where it goes and search in this knowledge base, get that context and the question, we send it to the large language model to wrap it up and make it a nice answer. So the heart of the key logic is retrieving that policy context, right? So that I'm going to classify as a tool, because that's the most important thing, right? So my insurance related or the generic offering of this agent, it's only we know, right? It DeepSeek or the large language model doesn't know those things, right? So this tool call is very important. We want to know at what time this tool call is happening. So this is our knowledge base call, and then we want to see at what time our large language model call is happening as well. How we start going through this, right? The first task we have to do is we just have to ensure that we enable those key parameters when our application is running, right? So if you can see for my LLM observability, these are the key things, right? DD LLM obs enable, and then I enable DD LLM obs ML app, and I gave the application name. So this is fundamentally one of the most important thing, right? And second, from a backend perspective, if, as I told you, I have two things. One is my knowledge base, right? So if I show you a quick glance of knowledge base, it has list of policies which I can go through, right? Which I defining the logic, right? Then we'll go to our main file where I am going to wrap these things. So the first when I make that LLM call, when I go to my agent, then there's a workflow happening, right? With the insurance agent. What I have done is we use something called this decoration. So we created this at workflow and tag it to this insurance handler agent. And with this annotations, with SDK is in the Datadog ddtrace SDK implementation directly inside the code, we are able to get what's actually this agent is doing, right? When it got the first question, right, asking, does my motor insurance cover EV break battery breakdown? Then what it does, it goes, it sends this to a knowledge base, right? So which I call as the tool. So here again we did the annotations in such a way that this being tagged as a retrieval of the policy context. So you have to understand that the first part is when my when the user asks that first question, which is the workflow, right? Which is the workflow which we tag into handle insurance agent. That's the insurance agent chat interface. And then what's the first part the agent does, or the our application does? It just goes and check or retrieve the KB article, which is I'm classifying it as tool, right? Retrieve policy context, right? And then what it does, we take that policy context, we send it to the LLM, which is our DeepSeek, and then we try to wrap it around and get my response, and then we send it to the user. So this again I wrap it like LLM. So we give that like what is the model we are using, the provider, and the other details, right? So this allows me, so I can look at these three things now very clearly. So let me go back to the presentation deck, and let me put it to present mode. Yeah. So this is very important. So how our spans we have uh, built, right? So we have the workflow, we have the tool, and we have the LLM call, and we are using annotations to enable this. So next, once we enable all of these things, we'll have to go to our Datadog and we'll go to APM section. First, we will see what are the traces, what are the services visible within our application. So I'm able to see the insurance chat interface, and I'm able to see my insurance chat front end as well. So there are a lot of errors so which we generated for troubleshooting perspective. I am able to look at it a high level view as well. So I am able to see the request, error, the latency, and all the other standard details. Yes. So from a trace perspective, if I go to the trace explorer, I'm able to, let's put it for last 1 hour, and we are able to see the traces. Right. So these are the key calls happening here. This is the time where our API chat is getting invoked, and this is the time where tool, which is our knowledge base, and then we have uh, the LLM, which is the DeepSeek call. So all those things are visible here. So if I look at insurance chat call, you can see traces. We have the we have the insurance the from there's API call for chat, and then we have the workflow, which is like the handling of that request, and here directly it goes to LLM. And let me just minimize it. Yeah. So let us just check a good trace where we can go through in detail. So let me filter it for last 30 days, 30 minutes, and then I just look at one flow, and let us go through this carefully, right? So yeah, in the flame graph, what you see is there's this API chat with the request comes to our agent, and then agent invoke the workflow, and then ideally what should happen is that if you remember, agent invoke the agent get the chat message, which is the workflow. That's my insurance support EV battery. And then we do a tools call just to validate, get the policy detail, and then only we go to DeepSeek, right? So it's not here, and one of the reason why it's not here is probably it's a very fast call, right? But if you can see, these are the breakdown. This is our the UI chat interface. This is the 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 Python which is doing the work, and this is the DeepSeek, right? So what probably we can go is we can go to the waterfall and see what's happening. So there's a insurance chat front end, right, which is post a chat message. It took around 1.94 seconds, and we are inside the chat agent now. Here we started the workflow, right? You can see the workflow is happening, and this is the fast call I mentioned to you, tools call, right, which is super fast, right? So it does it do a validations within this, and then it goes to the large language model, DeepSeek, to get that other related details, and then it create the the chat completion, and then send the det it get the it may so it trigger that LLM call, and then it send it to a DeepSeek, and then it finally get the response. So this is the most important stuff that we want to cover, part of our this LLM observability implementation. So I'll go through this again so that you have a very clear view. So the insurance chat front-end API chat, which took around 1.94 second, that is that RAM span, right? Which was the browser fetch. The user sent that respond the question to our chat message. Then we have the insurance chat agent post API chat, which took around 1.25 second, which is the backend entry span, which is that making the fast API receiving the request. Then we have the insurance chat agent workflow, which took around it's exactly the same 1.25 second, which was the handle insurance chat workflow, right? So which is now we are within that workflow span. Then we have the insurance chat agent tool, which is that super fast nanosecond call, retrieve policy context. So that is the knowledge base lookup for that particular question. Then we have that insurance chat agent LLM, which was uh, the call LLM. So it's just the LLM span, the beginning of that LLM span. And then we have the insurance chat agent create chat completion, which is part of auto instrumented span from OpenAI SDK. And then finally we have the actual DeepSeek outbound HTTP call. So it's not a it's a the DeepSeek call. It's always happen after our tools call, and then we get the insurance chat agent and the agent fast API serialization. So once we get all the data, fast API convert to a chat response, and then send that JSON back to the front end. So this is how this 1.94 seconds actually went, right? 0.7 seconds it was the network transit, and it was like a fast nanosecond retrieval from uh, the KB knowledge based retrieval, and I think like we spent like good 1.24 seconds waiting on DeepSeek, right? So this whole story, tools 162 nanoseconds, LLM 1.24 second, and total workflow is 1.25. So essentially all backend processing time is the LLM call. And so LLM create chat completion, HTTP request, and everything. It took around 1.24 seconds. So you kind of get the big picture, right? So you get to see everything from front end to the back end to your the large language model and the entire cycle, right? So this is what naturally we would like to see part of this kind of implementation. So the before I move into our next part of things, so one key thing, right, what you have to understand is, so out of this 194, the user waited 1.24 seconds, which was the DeepSeek call, right, which was the longest and which actually con took the most amount of time here. So these are the kind of things we need to be identified part of our APM or the full stack large language model observability enablement. So next place we want to go is, so this view is very familiar for you, right? Because this is Datadog console and APM section, which is a very known place for all of you. So we also want to go and see Datadog has this new place where it's looking at observability, especially the AI observability is this AI observability area. Here, because we use the annotations in a proper way, now our application start appearing. So I have my insurance agent here, and you can see I get all to see all the data, right? So I'm able to see my error rate, the duration, estimated cost, the token usage, and LLM calls. So this is the quick summary of my traces, what's happening. When I'm going down, I'm able to see what are the errors happening within my application. I can see built-in runtime errors, built-in timeout errors, my any other authentication errors and rate limit errors. So all those errors are visible here. So again, errors I can see from the API authentication or business runtime or rate limits, DeepSeek related errors, anything. And I kind of like we did a policy fairness check as well. So we want to see like we did the evaluation. So evaluation is something called now in this particular one of the key thing of this application is a user ask like, does my motor policy support EV battery uh, failure, right? We also want to ensure that the response uh, provided are uh, agreed with the policy, with the faithfulness, right? So there was a ability for us to validate that like how many queries were supported uh, by agent when the users come in, how many of our supported part of agreeing with our knowledge base and what we have the policy, and how many were not part of the policy. So let me go a little deep. So here what we want to do is so it's actually when you say supported and unsupported agreement is, so this is the one whether let's say uh, our DeepSeek doesn't know about our policy, right? So it's only knows that uh, what we are providing part of our context, right? So but over a period of time there can be a hallucination where user asks like, are you supporting my EV battery failure? And our agent goes and reply, yeah, we support, and we are supporting up to $1,000, right? where that $1,000 comes in, right? It's not, it's AI is trying to invent something out of thin air, which you call the hallucinations, and those kind of things are very dangerous because it's sharing something which our uh, the policy is not within our policy, right? So here Datadog come up with some new implementation where I can go and create a evaluation for a hallucination, and then I can do a policy check, right? Here basically what I'm doing is, right, one the we will go through this in a very detailed part of the next session, but here the once we do this configuration, the actual user questions and the message goes to DeepSeek, we will be validating in a way with another judge, right? So here at the moment for judge, I am using OpenAI GPT-4, and we can do a validation to check whether whether our agent has replied correctly, right? So here you can see but there are still unsupported calls, right? So I did a lot of testing. So, so just to prove that, like, that we are able to identify places where agent is not doing a proper job, right? So example for hallucination is, I'll quickly show. We have a one scenario where we ask a question about what is the exact payout amount if I lose a diamond ring while traveling, and how many hours does claim process taking time, right? It's bang, it just says 750, it gives time, but this is probably a hallucination, right? And let me retest this. One good news about our implementation is the same thing about this diamond ring. Now it start appearing here. So probably I can do a quick test. Yeah, it's a evaluation fail, right? Because it's hallucination. Because we never had like policy providing more detail about these numbers and all those things, right? So that's how the evaluation happens. It's a quick thing, but it's very nice. We will go more detail into troubleshooting with uh, LLM observability in another session. So we again see the cost, token usage, uh, and I kind of like we see the breakdown of tokens, the input token, output token, estimated cost, and the tools is my retrieval policy, which is the call I'm making to the KB knowledge base. So you can see, like, they have a 61% call and the errors and all those detail, and the prompts. We see the latency, slowness, and pretty much everything, right? Like this covers everything you should know in and out about your application. So it gives a very clear overall detail related to your application, so that you are fully aware of what's happening inside your application. So this is how we are able to enable very good, complete end-to-end observability for AI native applications. With this, what we'll do is we will go into the other aspects. Next is real user monitoring. So this is straightforward. This is straightforward, where we are able to get that code snippet and put that into our the front end code, and then front end code will start providing you the real user related, performance related data. So this is overall performance of my application. And then finally, we are able to go to our So we cover APM drastically and our continuous profiler. So again, like we enable DD profile enable true and DD profile expert exporters to agent, and this will enable me to get all the profiler related stuff as well. So I can go to Profile Explorer and I can see my insurance agent from the CPU usage perspective and others. So, so this is very important stuff. So this will allow us to get more insights. I think I I can remember there are some insights it gave me initially. Yeah. So the good news is this will allows the profiler, and this will give us that the next level details we would like to see from in our application. And with this, we enable everything, the full stack observability for our application. And let us just go and uh, maybe we do a KB crash, right? So if we go to our, and before that, maybe if we go to our APM, we should be seeing a fail traces. AP chat, see, the tool call is failing now with the error, and so there's a knowledge base unavailable, vector index checksum issue. And the good news is everything is now correlated with our logs as well, because we enable logs in, we did that mapping correctly, so that I'm able to see this uh, the logs, right? So I have very limited logs, but I can put more logs, and it will start seeing as well. And in case if I ask a pretty decent questions like a standard question, so yes, so international travel insurance covers this. If we come to our, see, that call is successful, we are able to see the flame graph. And then I would generally like to go through this waterfall because it shows me clearly how things are going through. My tools call is very fast, and then bulk of my time is spent for the DeepSeek call. And I see logs at this time, what's happening inside my application, and I can see what's happening inside. So kind of like, probably the data is not yet coming. So I should be able to see what's happening within my infrastructure as well. And then it's from the RAM, the browser front end, which has made that API call. So I get to see the complete full stack observability for this particular application with my the front end call, the business call, my knowledge base call, and the LLM call, and everything. So this is what we say AI native full stack observability. With this, so once everything is here, you can see the web request. We can see the time we spend for our LLM related work, right? Our tools call and the DeepSeek call. Uh, so we are able to bring everything together to get this view. So final story, we used Datadog infrastructure monitoring. So we configured Datadog Agent. So I was able to get the infrastructure related metrics. And very important, we get ship the logs to Datadog as well with this configuration changes. And one small change we did was we we got that um, the log ingestion true, so that we are sending the trace ID and span ID with our logs, so that I am able to correlate with traces. So then we enable LLM observability. If you remember, it was three part. We look at the workflow, which was that chat API call. We look at the tools call, which is that knowledge base call, and we look at the LLM with LLM obs annotation, so that I am able to look at all three aspects. And we did the real user monitoring, and of course part of the Datadog infrastructure agent installation, I enable the Python when I did that, so I got that APM out of the box as well. So that's part of DD traces, and we enable continuous tracing, and which was part of that environment file configurations. So all of these things allow us to build a comprehensive full stack application, which allows us to uh, have a clear view of our application. So what this implementation actually deliver? So this is a very small POC, but it's provide how we can build much uh, bigger things, right? It's the framework or the blueprint. If you are working in an AI native application, what sort of full stack observability you should look at, right? So we look at infra, APM, large language models, logs, RAMs, profile, right? Those are the key things. Then we look at the full request flow, our web request to the workflow, to the tool, to the LLM, to the round trip, right? That's how AI native applications will work now. And we look at how we can do the logs to traces correlation, which is very important in this area. And one other thing is like I show you with these hallucinations and all, we are able to looking at the prompt as well, right? We have the visibility of tokens, and probably that's something let me go back and just we will spend little more time here. So if I go to my AI observability, and I should able to see, let me go inside the insurance the application, and I think I have seen, yeah, I seen the prompts, right? You should we will see how the 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 prompt performance as well, right? So this is a very uh, important thing, right? Like we can go and see what are the prompts and how these prompts are being evaluated as well, right? So the when I go inside my evaluation tracker, each prompt, right? I was able to see those spans here, right? So this is a very important uh, granular level detail, right? If we want to have a control. So that's called this full prompt and the token visibility. And so we get to the bigger picture, right? With AI native applications, we want to know obviously the baseline, right? The standard stuff like about the front end, the back end performance and all those things, right? Then it's about your knowledge base call, it's about the LLM calls, it's about the prompt, it's about the token usage, and all those things are the key new things you have to be mindful, right? So I hope that this session was useful. This session allows you to get a quick overview of how we do a uh, implementation and enable these capabilities. And I'll have a follow-up session. We will go through some of these error scenarios and then we'll sit together and see how we can use this implementation to troubleshoot, to identify root causes of those failures. So thanks everyone for taking this time, and I'll see you in the next session. Take care. Bye.